Question 6. Copper can be produced from rock that contains CuFeS2. Balance the equation for the two stages in this process. This is a really tricky 2 marks for balancing equations. Well, if you do it successfully, you should get 4 CuFeS2 plus 9.5 O2 plus 4 SiO2 arrow. Nothing here, 7 SO2 plus 4 FeSiO3 arrow. Nothing there, 2 Cu2O, 6 Cu plus SO2. I might go this part of question 6.1 in a separate video, going in detail on how to balance it, because it's pretty tricky. But for today's video, for the whole question 6, I'm just going to give you guys the answer for the balancing of the equation. And 6.2 suggests 2 reasons why sulfur dioxide byproduct of this process is removed from exhaust gases. Number 1, it's toxic, and 2, prevents acid rain. And there's other things you could talk about: improves atom economy, reduces waste product, reduces need for sulfur mixing, used to produce sulfuric acid, but toxic / breathing problems, and prevents acid rain are your to-go 2 reasons. Toxic / breathing problems causes breathing problems and then prevents acid rain. And acid rain damages buildings / ecology. 6.3, 6.4, that's it. 6.3. A passenger jet contains 4,050 kilograms of copper wiring. A rock sample contains 1.25% of CuFeS2 by mass. Calculate the mass in tons of rock needed to produce enough copper wire for a passenger jet. Let's break down the question. Calculate the mass of rock needed to produce enough copper wire for a passenger jet. Calculate the mass in tons of rock needed to produce enough copper wire for a passenger jet. And 1 ton equals 1,000 kg. Most people would know that, most students would know that, but if you didn't, there you go. Of rock. Okay, so first thing we can do is going to be calculating the moles. Now the moles of what exactly? Well, the moles of copper, Cu. We know it's moles mass in grams, so 4,050 kilograms times by 1,000 to get into grams, divided by mR, which is of copper. mR of copper is 63.5, where 11 is that first one, 63.5. Now that will give me 63,780 moles of Cu. 63,780. And now if I want to find the mass of what? The mass of CuFeS2, the mass of copper is going to be the moles times by the mR. So moles is mass of mR, so mass of CuFeS2 equals, because of 1:1 molar ratio, it's going to be moles over mR. Mass is moles, 63780 times by mR of CuFeS2. Copper is 63.5. Fe is 55.8, and S2 is 32.1 times by 2. That'll give you an MR of 183.5. Therefore, we get the mass of this is 1.17 times by 10 to the power 7 grams. And we know a rock sample contains 1.25% of CuFeS2 by mass. And we're trying to find the mass of rock needed to produce enough copper wire. So we're going to times this by is 100 divided by 1.25. And what is 100 divided by 1.25? It's 80. So we're going to times it by 80. And that will give me 900, 1.17 times by 10 to the power 7 times by 100 divided by 1.25. That'll give me 936 million kilograms. But we want in tons, so we're going to divide. No, that'll give me 936 million grams, mass in grams. So if we divide it by 1,000 to get into kg, but we want tons, so divide it by 1,000 again, so that'll give me 936 tons as a mass of rock. So moles of Cu, the mass of CuFeS2 mole to molar ratio. Then we want to times it by 100 divided by 1.25 because the rock sample contains 1.25% of CuFeS2 by mass, and then convert it into tons. It says 6.4 copper can also be produced by the reaction of carbon with copper to oxide according to the equation 2CuO plus carbon arrow TCu plus CO2. Calculate the percentage atom economy for the production of copper by this process. Well, atom economy, percentage atom economy equals MR of desired products all over MR of all reactants times by 100. 100 times by 100. So MR of desired products. And remember to include the moles. So we're trying to calculate percentage atom economy for the production of copper. So the MR of desired product, copper, which is 63.5, but we've got 2 moles of it, so it's going to be 2 times by 63.5 divided by MR of all reactants. Well, it's going to be 2 times 63.5 plus 2 times by 16 plus 12, 171 times by 100. So 2 times by 63.5 divided by 171 times by 100, 74.3%. That's just 3 significant figures. So memorize the formula. Percentage atom economy is MR of desired products over MR of all reactants times by 100. In this case, it's not going to be the whole products. It's going to be the desired products. What do we want? We want the production of copper, not carbon dioxide. So it's going to be copper. We also have 2 moles of copper in the equation. So we need to times the MR of copper by 2, divide by all reactants, not just copper oxide, plus it's going to be copper oxide plus carbon, and also times the copper oxide by 2 because we've got 2 moles. And then times it by 100. So MR of desired product over MR of all reactants times by 100, and you should get 74.3% to 3 significant figures. And that is the end of question 6.